Hello, everyone. So 2 years ago, in summer 2023, Dataiku, which is developing an AI platform, made two ambivalent decisions. The first one was to start to work on GenAI-powered features to boost the productivity of its users. And the second one was to prevent developers at Dataiku to use GenAI tools to code, such as copilots. 2 years later, with Aimee, we're here to draw some conclusions out of these two decisions. What are the consequences? So first, Aimee, who is a senior research scientist, will explain how we developed GenAI-powered features to help our users leverage the platform in the best possible way. And then Marine, me, who is an engineering team lead at Dataiku, I will explain how it impacted the life of developers here.
Thanks, Marine. So for those of you who aren't familiar with Dataiku, we build DSS. It's a platform for building data science and AI applications. It's aimed at a wide variety of users who have different levels of technical skills. And the goal is for them to be able to collaborate on projects together, to be able to openly see what each other is working on and build upon it. So our users can work in visual recipes, so recipes for data transformation and modeling, or they can code directly in Python or SQL. So the goal of the AI assistants that we've been building is to boost the productivity of all of our users. So what have we built? We've built some assistants to help onboard our users onto the projects that their colleagues have built by asking the AI to explain the project or a part of the project or a piece of code. We have built Copilot style assistants for helping to build the visual recipes. So this helps new users because they don't need to learn all of the terminology, and it also helps experienced users not needing to actually go through and manually put in all of those parameters in the visual interface. We've built code assistants for Python and SQL to help our users get to that first version faster. And we've built a dashboard assistant to help generate insights to share on a given project. For all of the assistants which generate an artifact in the platform, the user has to stay in the loop and validate it before they can save it. So once we have an idea for a new assistant or even a POC, how do we go about turning that into a reliable AI-powered feature? So the first thing we do with any engineering project is to sit down and come up with clear specifications. What is the scope? And importantly, what is out of scope for this first version? But when you're working with AI-powered features, it's also really important to start thinking right from the beginning about how are we going to measure the success? How are we going to know if this assistant is actually doing what we think it's doing when we release it out there in the wild for our users? And sitting down and thinking about this right at the beginning helps us to build modularity into the system, to try to break down some of the complexity into smaller subsystems that we can reuse across our different assistants. And it also helps us to build verifiability into the system and to make sure that we're tracking everything that we're going to need to look at whether or not we're being successful. And this helps us to build debuggability right into our system from the start. So there's always technical questions such as build or buy when you start any project. And at Dataiku, we've chosen to leverage the OpenAI models to build our assistants. We've set up an architecture where we have a dedicated server for all of our AI assistants to work on. And from there, they can call out to OpenAI, and we can log all of the incoming queries that we receive from our users and all of the responses that our assistants generate. We've chosen to work with the API-based pre-trained models without doing any fine-tuning for 3 reasons. The first is simplicity. It means that we don't have to handle the infrastructure for self-hosting, and we don't have to build very large fine-tuning data sets. The second is responsiveness. We don't need to redo any fine-tuning every time the model changes and a new one's released. And the third is flexibility. This setup allows us to easily change models from one provider to another if a new model should be released that performs well for one of our assistants. So once we deploy an assistant, we want to be able to measure how our users are actually using it and how well it's actually responding to our users. We're aiming for full observability, so we want to make sure that we're tracing that request all the way through the process. So we want to log the request that we're getting, the generation that we get back from the model, the results of any post-processing we're doing, and all of the validation that's happening on the back end of our DSS server. And we're also logging any user feedback that we're lucky enough to get about whether or not the generation actually met their needs and their expectations. As well as measuring the performance and debugging, this is really useful for helping to understand how people are using it, what are their expectations, and if the scope that we defined in the beginning is actually relevant or whether or not that needs upgrading for the next version. One of the hardest parts about engineering any product where you've got generative AI in the mix there is trying to accurately measure whether or not you're being successful. Typically, LLMs give you quite open-ended generations. It's difficult, sometimes impossible, to just check whether or not it matches a reference answer that you have. There may be more than one correct answer, and in production setting, you don't have a reference answer to compare to anyway. We found that it's much more useful to have a composite set of metrics. So typically you want to have some objective metrics. So this may be, does it pass some of the validation that we have set up? It may be looking at the length of the response that you get back, and subjective metrics as well. So this could be something like helpfulness, or it could be how faithful it's being to those retrieved sources if you're doing a RAG application. If we take generating SQL as an example, the first thing you're going to check is that it's valid SQL, but that's not really enough, because just because it's valid SQL doesn't mean that it's answered your user's query, and it doesn't necessarily mean that it's answered all of your user's query. It might only answer one part of it. And so this is a subjective judgment that we need to make. And ideally, the user would make that for us, and they would give us feedback on every single query, but we're not that lucky. I don't think anyone's that lucky. So one of the ways that we can handle this is by using the LLM as a judge to try to evaluate against a set of criteria that we've laid out to determine whether or not we've got a functional success. And for each one of the different assistants, we have different criteria for success. And so we're going to have different combinations of metrics. I mentioned that we're building debuggability in right from the start. So more concretely, what this means is that when we're breaking down into modular systems, we can set up components that have smaller prompts. So the more instructions you have, the more brittle it can be trying to prompt engineer without breaking another part of your system. So breaking down into smaller components helps with the robustness. We're doing comprehensive logging at every single step of the generation, but also once we start implementing any actions that an assistant might recommend, we log at every step of the way. And as well as being able to measure performance, this allows us to step in and replay some of the solutions to try and fix errors that we've pinpointed in the system. And having all of these different detailed metrics gives us a holistic picture of how the assistant is performing, which helps us to pinpoint which of the instructions are being followed and which ones maybe need a bit more work. By tracking all of the validation and error messages as we implement all of the assistant's actions, we're also able to count how many of a different type of error that we actually see to know what are some of the most common error modes. And we're able to then test out using the agent to actually iterate on its own answers and debug. And one of the questions that we're grappling with more and more now as the architectures change very quickly is, to what extent should we decompose any AI assistant? I've touched on some of the positive points, like smaller prompts are easier to debug and that you can reuse some of the functionality that you've built into tools if they're general enough across different assistants. But there are some downsides to consider, that the more tools you introduce, especially if they have similar functionality, your model can start to have difficulty in knowing exactly which tool to use in which scenario. And if your different components are called sequentially, then you're introducing more latency into your system. And depending on those specifications that you set out at the beginning, that can be more or less problematic. So I hope I've given you an overview of some of the things we've been learning while building these AI assistants to help boost the productivity of our users. And now I'm going to hand over to Maureen to talk about how we're boosting our own productivity with generative AI.
Thanks, Amy. So as a disclaimer, for legal reasons, we are not allowed to use Copilot tools or generate tools to write code, because we are doing like an on-prem software, and so it's exposed on the internet, like you can access the package. And the GenAI tools may introduce some GPL license codes into the code base. And as it's a contaminating open source license, we don't want our software to become open source, because then other players may take the same code as we have. And it's not a very wise move for Dataiku business model to have everyone able to reuse the same code base to build similar products. However, developers at Dataiku are still leveraging GenAI tools in their work, and I wanted to understand how much they used it. So I started a little survey. I got 43 respondents. Most of them were software engineers, and so I analyzed the results, and then I interviewed 6 people during 30 minutes to get more insights into the use of GenAI. So most people were using GenAI, like 85% of developers were using it in their work, but not so always. Like most people used it once a day. So they used it with moderation. And the main finding of my sociological study is that GenAI hasn't revolutionized the way people work, developers work at Dataiku, because actually being a software engineer, it's not only about writing code, it's also about finding what to do and check if it's doing what you want it to do. And that's why writing code is not enough. And a lot of the work we do is actually not manageable by AI so far. And maybe in the future this will change, because as new coding assistants come up, it may become a greater opportunity for Dataiku to adopt these tools. But so far we haven't taken the full, like it hasn't really changed our life, basically. So people have been using GenAI tools across all the development cycle, almost, from learning, designing, searching, coding, and testing. And first, I will start with the most popular task. So people were using GenAI tools for code-related tasks. So especially useful for debugging. And it was interesting because when I talked to people, they told me that it was not only for copy-pasting error messages into ChatGPT, but also to have this interaction with chatbots, so that they could use it as a rubber duck. And even if the chatbot didn't give a right answer, it was a way to dismiss ideas that couldn't work. So it's really nice to have this interaction when you're trying to debug. Then they would use it for refactoring, so to make sure that they could write the most idiomatic code. And finally, a very interesting use case I thought was to prototype the code very quickly. So it's a way to visualize how your code could look like and have a very quick idea. And that way you can explore a lot of different ideas. In terms of tools, so chatbot interfaces were the most popular option. So ChatGPT, Mistral as well. And from what I gathered during interviews, people prefer chatbot interfaces because they had more control over the outputs. Even if some people liked autocompletion because it could help them type faster. The issue with autocompletion was that it may be distracting, so you may lose your focus. And also people complain because when ChatGPT or Copilot generates your code, you don't write it anymore, so it removes the joy out of coding. So that's an issue people highlighted. So what I want to ask to Mistral as a feature request is to have an AI that is able to review and test our code instead of having us review and test the code made by AI. However, when it comes to learning, actually, GenAI tools would bring more joy because using chatbots can make the learning process much more fun thanks to the interactions and the gamified experience that you can have on some tools. People would use it to learn about statistics, to learn about a new language, a new framework, and for onboarding at Dataiku. And also, it really transformed the way people would search for information, obviously. So it's like a new way to interact with the internet for some people. Very efficient to browse documentation for some languages or frameworks. And when I looked at the history of the prompts people had, I was quite surprised because it's always so specific. Like, people didn't ask very general or broad questions. They were really like asking specific questions. So I think it says a lot about the current capabilities of AI and how it can help us. We still need to guide it a lot if we want to work efficiently. And some people told me that GenAI tools completely replaced Google and Stack Overflow. But for others, they tried to reduce the dependencies to these tools, and they only used it in last resort, basically. More surprisingly, people would use GenAI tools to brainstorm about design ideas, so to explore about different potential patterns or design decisions they could take, like asking the chatbot, oh, I got this idea to solve my problem. Can you give me 2 more ideas to solve it? So I think it was a very interesting use case as well, because it's a bit more like artists or writers would use chatbots, like to really create new ideas, like in a very creative way. And finally, like GenAI tools are very helpful when it comes to testing, because you can automate manual tests with agents, for example. It can also help you to find edge cases, corner cases, and generate synthetic data sets for your tests. And it's a good way to reproduce bugs that customers have in production, but you don't have access to the data. So you can leverage GenAI to generate all this testing data. Oops. To summarize, so Amy showed us that AI engineering is a lot about transferring the best principles of software engineering into developing AI features. So there is not a dramatic change in the way we work on features, but we try to make robust AI features by leveraging existing software engineering concepts. And then my survey revealed that right now, GenAI hasn't really transformed the life of people at Dataiku. But it may in the future with the arrival of new tools such as Jules, Codex from OpenAI. So you never know. Thank you.
Thank you for the presentation. I have 2 questions. One is you talked a lot about recipes. I'm not sure what a recipe looks like. Is it a specific language you use for the recipes in the Dataiku? And also, you mentioned that the agents, they were debugging themselves. So how far does that go? Is it fully automatic? Does it work?
It's something we're testing at the moment, so we haven't deployed it yet. But we've seen good success with being able to feed back in some of the validation messages that we get from errors when we're actually implementing some of the actions. Depends how clear your error message or your validation message is. In terms of recipes, so this is a screenshot here. So over here you have, these are what we call visual recipes. So this is going to be basically a GUI interface to be able to click what you want in terms of data preparation. So for a prepare recipe, you might do something like renaming columns, for example, or other types of transformations, applying formulas.
Thank you.
Thank you for your presentation. Mine, I had a question is, you mentioned that your developers are not allowed to use Copilot or Cursor or any other tool for legal reason, because of licensing reason, that
Yeah.
you consider that if cursor? Well, can you explain, please?
It's if Cursor introduces some GPL license code into your code base, because it's a contaminating license, all your code base becomes open source.
Developer copy paste from the output of ChatGPT into.
Yeah, it's the same. Sorry, if a user, if a developer copies from ChatGPT, it's also likely that it will be, not likely, but it's possible that it's a GPL code, and we have the same risk by copy-pasting code from ChatGPT, yes.
What do you do in practice to avoid that? Do you have models trained on non-GPL code?
To avoid that in practice, we trust people to be responsible.
Is that your legal department that came up with that? Because it's, I suppose it's questionable. I never thought about it, but I suppose it's questionable. I mean, the output of the LLM is generated. It's been trained. It turned into a kind of mass of one and zeros and not like floating numbers. And then you put an answer and it generates some code. And this code you consider is a reproduction of GPL code, which in my sense is, yeah, I don't know, at least disputable. So how did you come up with that conclusion internally?
Arizo has an answer.
Maybe it's because of the dependencies. Like if you're telling, like your LLM tells you import this package, it's open source, don't worry. It's open source but GPL. You import the package in your code, it works. And then you publish your code, and then it's too late.
But also sometimes you have just a certain amount of lines of code which are exactly like a GPL license package. And the trial between Google and Oracle showed that only just 5 lines could end up in a trial. So it's quite risky actually to have any GPL license like code.
I'm just trying to understand, if you have GPL code in your base, does that mean that your whole code becomes GPL, or?
Yes.
Okay. So if I understand correctly, you have no open source dependencies in the whole Dataiku?
No GPL.
GPL, sorry.
Yeah.
Okay.
But other open source dependencies are fine.
Perfect. Thanks.
So just in case some people were having a heart attack here, there's plenty of tools, and I'm actually curious why you're not doing that, but there's plenty of tools available to check that post-mortem. So you let them do whatever they want, and then before you deploy, you check whether or not you're using GPL code. That's fairly trivial. You know, Black Duck is one such tool. So you just pay the fee, and then you go and check. And if they do, then you ask them to change it.
That's
which would make it way more effective. Wouldn't it?
Yeah, it sounds like a good idea. I will talk to the legal team as soon as possible.
Brilliant.
Any other question on something that is not GPL?
Hi, thanks for the talk. I'm curious how you use another AI system to evaluate the quality of the response that the first AI gave to the user. I'm curious if you can share a little more detail about that. Like, do you use another model in case there's a blind spot in the first one? How do you gauge how good the answer is? I'm curious about that.
So we can use the same model, but with a different prompt. So the way that we're doing it is we make sure that we give very detailed instructions to the judge model about exactly what the task is, what are all of the specifications that were given to the original agent. And then we have a detailed rubric that we ask the LLM judge to go through and check all of these things. So we ask it to simply output true or false. Does it answer the user's query with no technical mistakes and no mistakes of any kind? And then we give it a list of different things that it needs to check. So we ask it to check for things like logic errors. We ask it to make sure that the answer is complete, that it's addressed every part of the user's query. We ask it to check things like that there's nothing extra in the answer. It's not added some kind of extraneous feature that the user hadn't asked for. we found that compared to human labeling of whether or not we think that the response correctly responds to the answer, we get pretty good agreement, so around 80%. And we also ask it to output all of its reasoning about why it doesn't meet the standards if it doesn't, which allows us to have a better understanding of what it's picking up, which is extremely helpful as well for us to be understanding exactly the behavior of the model out there in production.
Awesome. Thank you.
Thanks a lot, then, Marine and Amy. And we're gonna then go with that.